there are identities, and traditionally everyone knows that these are the identities and keeps telling like sin square theta plus cos square theta equals 1, and everyone knows this. But the tricks are like how effectively you use them. First is use as is. Okay, use as is, meaning left to right, left to right. Okay, the second one is right to left. What I mean is when they give 1, there is a 1 in anywhere, you will be substituting, replacing 1 with the sin square theta plus cos square theta, right to left. This is right to left. Okay, the third one is modified. This is the one again, quite uh, quite many times we use this. Is you will say sin square theta equals 1 minus cos square theta, or cos square theta equals 1 minus sin square theta. These are all the things. Actually, the third one is the one which actually eats the brain. Okay? We don't know when we'll be using what. Okay, and in the same way, take a square root of it and then do it both sides. Then here also take a square root and then use it both sides. So that's what you need to be looking at, the convenience of using whichever is the formula. Okay, the same goes with the other two things, like 1 plus tan square theta equals secant square theta. So again we look at it and say, how come this one is on this side? I mean, it should have been the other side. Okay, that's why in fact the best form for the second one is secant square theta minus tan square theta equals 1, and then you apply all the three. Okay, you can use as is, left to right, right to left, and modified. Okay, why I recommend this is, because let me see the third one also. You have cosecant square theta minus cos square theta is also equals to 1, is also equaling to 1. So what do I mean now, why I put them like this? So wherever you see 1, 1 can be replaced. 1 can be replaced by looking at which one, either to use this or this or this. How do I decide? So very simple. Okay. Oh, you want? Yeah, yeah. Tell me. I'll tell you. Yes, we have to decide from either three, especially replacing the one. So when we say replacing the one, for example, there is something like I have cot square theta minus cosecant square theta, okay, and plus 1. Okay, so this is there, and they'll say simplify. This is what they'll ask, simplify. So when we say simplify, now you try to just see there is a formula connecting this, or there is a formula just for this, or whatever. But then the easiest thing is look for this one. This fellow is sitting here, and therefore we better use the third one. We better use the third formula. Okay, this is what I mean by depending on. So what is the third formula? Cosecant square theta minus cot square theta equals 1. So you replace this 1 with this. So that translates into cot square theta. So don't disturb this one, because these are like heavy things to remember the formula. This is easier formula to remember. So cosecant square theta, and plus you just substitute this cosecant square theta minus cot square theta, right? So everything get cancelled, equals to 0. Okay, so this is difficult to remember, that's why I'm saying look at that one. Okay, another scenario, yeah, you'll have another scenario like that, is for example 1 over cos square theta minus sin square theta, or rather I think maybe the better one is cos 1 divided by sin theta plus cos theta whole squared. Okay, so in this case no need to do anything. First simplify. So you'll have 1 divided by sine square theta plus cos square theta plus 2 sine theta cos theta. I am using the identity of a plus b whole squared. Okay, so then you replace this by 1. So this is a part of the simplification process. So whether they ask us to replace this one or not, we must in trigonometry.
So when it's sine square theta plus cos square theta, it should replace with 1.
Yeah, is replaced by the 1, right? That's this. Yeah, 1. So when we are actually learning this, the easier way to say, whenever you see again now 1 plus 2 sine theta cos theta is what you are seeing. Okay, and then they say simplify or write this as a square or whatever, simplify. Okay, I will still suggest this divided by sine theta plus cos theta. So this is the question. Okay, then we should not look at all these things first. You should look at the 1 here. Can I replace this 1 with something? Okay, yes, of course. You then think of sine square theta plus cos square theta. You replace the 1 plus 2 sine theta cos theta whole divided by sine theta plus cos theta. So getting this into the mind, saying that yes, this is the one I should be working on now. Okay, that's the trick. So if you go backwards, now what is that we used in this? We use the right to left. Okay, from 1, yeah, we went from right to left. Okay, so this occurs most of the time. If you don't use that, any other method will not help here. Okay, so by reorganizing and combining, I write the numerator as sine theta plus cos theta whole squared divided by sine theta plus cos theta. So now divided by this one, same thing is there, right? Yeah. So get the answer as yes, correct. So these are like, each problem will it appears as if you have a different technique you are using. It appears, but it's not actually. Okay, so you're always looking for that, where is that one, whether the one is visible, and you are using that one replaced with the one form of the identity or not. Okay, so that's one thing. And the second thing what we normally observe with these are like the tricks or whatever the small tricks what I am telling. See this a squared minus b squared form, especially with the formula 2 and 3, because in that only you have secant square theta minus tan square theta equals 1 and cosecant square theta minus cot square theta, because that's where you have the minus coming here, whereas for sine square and cos square you have the plus coming. Okay, so since you are getting this 1 in these cases, it actually gets transformed using this formula. That's nothing but secant theta plus tan theta multiplied by secant theta minus tan theta, right? A plus b and a minus b equals 1. Agree? Yeah. Secant theta, this is a plus b, a minus b will give you a square minus b square, isn't it? A plus b and a. Yeah. So similarly, cosecant theta plus cot theta multiplied by cosecant theta minus cot theta equals 1. These do have a high significance, meaning the previous one when we use the sine square theta plus cos square theta, this fellow is actually sum of the squares. This is nothing but the sum of the squares. Is also called sum of the squares. Sum of the squares. That means you have two squares and you sum them up. These two are difference of squares.
Okay, which two?
The two formulae which I have, secant square theta minus tan square theta,
Both.
these two. These two.
Oh,
It's a difference, right? This is a difference we are talking about. So you have two squares and you are saying the difference of them, that is equal to 1. It's like a terminology. Like you say in English, like this the top one is the sum of the squares. Squares of what? Square of sine and square of cos. This is a difference of the squares. I mean, you are taking the difference of the two squares, and that's why you are getting 1. Okay. So what this gives is, like if I have secant square theta minus tan square theta, of course you can write this as 1. This also gives to me that secant theta plus tan theta and secant theta minus tan theta, these are reciprocals.
okay. Oh, they.
Yeah, this the sum of these and the difference of this, they are reciprocal to each other. That's why this is kind of, second and third are important as well. Let's suppose the question is directly this only. Okay, prove that these are reciprocals, or prove that secant theta plus tan theta equals 1 over secant theta minus tan theta. If this is the question, then you could go from left side and then come back to the right side. You can prove it. All right. So how do I move from LHS? Left hand side. Okay. Multiply and divide. Multiply and divide this. Hello? Can you hear me? I lost your voice. Ranjit, are you there? Hello? Hello?